We're looking at Chapter 8, Sinusoidal Functions, Sections 8.2 and 8.3. In this lesson, we're going to explore periodic functions. We're going to use graphs to investigate characteristics of sinusoidal functions. Specifically, we're going to look at the domain of the sinusoidal function and the range, amplitude, midline, period, and the maximum and the minimum. So if you can recall from 8.1, we changed radian angle measure to a degree measure by multiplying by 180 degrees over pi. We also changed from degrees to radians by multiplying by pi over 180 degrees. Let's just look back at the previous chapters. We looked at some different functions. In Chapter 5, we looked at a linear, quadratic, and cubic function. In Chapter 6, we looked at an exponential function. In Chapter 7, we looked at a logarithmic function. We also investigate each different type of characteristics of these functions. Some x-intercepts, the y-intercept in behavior, domain, range, number of turning points, things like that. Now we're going to look at characteristics of sinusoidal functions. So first, let's have a look at what a periodic function is. Periodic function is a function whose graph repeats in regular intervals or cycles. So as you can see, it repeats its cycle. Here's another periodic function, and another periodic function. When we look at a sinusoidal function, it's any periodic function whose graph has the same shape of that as a sinusoidal function, as y equals sine x. So this graph right here is periodic because it repeats over intervals. It has the same cycle. Yet it's not sinusoidal. This graph is also periodic, but not sinusoidal, since it doesn't have the same shape of y equals sine x. This graph right here is not periodic, nor is it sinusoidal. It doesn't repeat in cycles. It does go up and down, but it doesn't go between the same interval. And this graph right here is a sinusoidal graph, the waves, and it is periodic, of course. So when we're looking at a sinusoidal function, we have this wave pattern, and there's specific characteristics we are going to look at. So if we look at the sine graph, the local maximum, or the maximum, is the highest point on the graph, the highest y value on the graph. The minimum is the lowest point on the graph, so here we have the minimums. Okay, they are y values, of course. The period is the length of interval of the domain to complete one cycle. So to go from maximum back to maximum, or to go from minimum back to minimum, this length from here to here in the domain would be the period. The midline is the horizontal line halfway between the maximum and the minimum. So if here's the maximum, here's the minimum, halfway in between, there's a line called the midline. The amplitude is the distance from the midline to the maximum, or the distance from the midline to the minimum. So from the midline to the maximum, or from the midline to the minimum. Of course, this distance must be the same. And it's always expressed as a positive number, even though this would give us 1, 2, 3, 4, 5, 6 units down. It's expressed, the amplitude is expressed as positive 6. So let's have a look at a sine graph. The function y equals sine x is a periodic function. So here we have y equals sine x. There's some key points here. You go from midline to maximum to midline to minimum to midline. That's the 5 key points of a y equals sine x graph. The period, of course, is where it goes from maximum to maximum. So here we have from 90 degrees to 450 degrees, which would give us a period of 360 degrees. Sorry, 360 degrees. The amplitude in this case is the length from the midline to the maximum, which would be 1 unit, or the midline to the minimum, which would be 1 unit, of course. Amplitude is 1. So here we have, like I said, there's 5 key points of a sine graph, 5 key points. And those key points, when you look at it, it goes from midline to its max, then back to midline again, then to its minimum, and then to midline. So any graph y equals sine x goes from the midline to the max, to the midline, to the min, to the midline again. Let's have a look at this one. We still see the period here. The period of this one is a little bit, we have it in radians here now, not degrees. So it's the period here would be from the sinusoidal back to the sinusoidal the second time, or from the maximum to the maximum, which is a little bit more than 6. Here we have the amplitude still being 1 unit. And once again, it goes from midline to maximum, midline to minimum, to midline. So let's have a look at another sinusoidal graph, periodic function. The function y equals cos x is a periodic function. In this case, it goes from maximum to midline to midline, back to maximum. So it's a little bit different of a wave. It has 5 key points. It's 5 key points here. Is the maximum to the midline, to the minimum, to the midline, back to the max. So it's a little bit of a different order than the sine graph. Of course, the period is still the same. How it goes from the maximum back to the maximum. So here we start the maximum at 0, and it goes back here. So we're looking at the domain. It's 360 degrees for this case. Same goes for this one. We have maximum to midline, minimum to midline to maximum. We can see the period is where it goes from maximum to maximum. So let's have a look at an example here, where we have our domain is in radians. We are going to look at our maximum point first, and our maximum point is right here at -0.5. Our minimum is right here at -1.5. And our range, of course, is from our minimum to our maximum. So we have -1.5 is less than or equal to y, which is less than or equal to our maximum. And y belongs to a set of real numbers. So our midline is halfway in between our maximum and our minimum. So here's our max, and here's our min. So halfway in between would be our midline. So the equation of the midline is y equals -1. Our amplitude is the distance, the vertical distance from our midline to our max, or from our midline to our min. And here we have from our midline to our max is 0.5. Remember, amplitude is always positive. Now the period is how long it takes to go from max to max. It's also the horizontal distance between the max and the min represents half the period. So if we go from our max to our min, that represents half the period. So to go from our max to our min, so our max would be right here, and our min is going to be right here at 2. So that's 1 to 2 would be 1 unit, and that's half the distance from our max to our min is half the distance. So 2 times 1 would give us, the period of this one would be 2. Let's look at another example. Here the domain is in degrees. We have our maximum. Here is at 3. And our minimum is right down here at -7. So we have our maximum at 3 and our minimum at -7. Our range is always our minimum is less than or equal to y is less than or equal to our maximum. Y belongs to a set of real numbers. Our midline, you have to be very careful too, because sometimes we may pick the middle and it's not really the middle. The midline is halfway between the max and the min, so we have the max here at 3 and the min at -7. So that would take us right up to -2. So here's our midline. So let's just make sure that gives us 1, 2, 3, 4, 5 units to the max, and it gives us 1, 2, 3, 4, 5 units to the min. So the equation of our midline is y equals -2. The amplitude, which we just counted, is the distance from our midline to our maximum, or midline to our minimum. And the amplitude is always positive. 1, 2, 3, 4, 5. Our amplitude is 5. And our period, we may be able to see it a little bit better here, is how long it takes to go from the max to the max, or the min to the min. It's also how long it takes to do one complete cycle. So from here, from our sinusoidal, or our midline, we go from maximum back to midline to minimum back to midline. And that's 180 degrees would be our period. Let's have another look at a different example. You may want to pause the clip now and attempt this one on your own. We have a maximum of, looks to me like this is 7, but it's 6.5. Have a maximum of 6.5. We have a minimum of -0.5. So that would give our range to be -0.5 is less than or equal to y. It's less than or equal to 6.5. Y belongs to a set of real numbers. So our midline is halfway in between our max and our min. This would give our midline to be 3. I'm just going to check to make sure. I have 1, 2, 3, 3.5 units to the minimum, and 1, 2, 3, 3.5 units to the maximum. So it is y equals 3, and our amplitude is 3.5. We have the distance it takes to go to the max, from the max to the next max is our period. So we can have a look here. We go from max at 0, and to go all the way to the maximum again is 5 units horizontally. It's also 2 times the distance, 2 times the length time it goes from the max to the min, or the min to the max. But we can see here it goes from max to max after 5. So our period here is 5. Sketch the graph of the sinusoidal function with the following characteristics. So here we have some characteristics, and we have to sketch the graph of a sinusoidal function. If you'd like to, you could pause the clip. I'm going to continue. Just going to sketch a graph here. And we have a domain x such that x is between 0 degrees and 360. And we have a range of -5 to 9. So that means that -5 will be the minimum, and 9 is the maximum. It also gives us a period of 120 degrees and a y-intercept of 2. So if we go from -5 to 9, we have 2, 4, 6, 8, 9. So we have our maximum up here. And we have 2, 4, 6, and our minimum right here at -5. If we take the period, which is 120 degrees, and divide by 4, each one of our points will go up by that many degrees. So we're going to have our points go by 30 degrees. So we have 30, 60, 90, 120, 150, 180, 210, 240, 270, 360. And so we always start with our sinusoidal function. We start at our midline, and our midline in this case would be 2, since it's halfway between 9 and -5. Change colors here. So our y-intercept is 2. That's right here on our midline. And our maximum, that's our next point, is 9. Then our next point will go back to our midline. And then we're down to our minimum. And then back to our midline. So we're looking at the graph like this. We want to do it till we get to 360. So we're going to go back to our max again. And then back to our midline, down to our minimum, and back here to our midline. And I'm going to change colors to continue. And one more, we'll go up to our max, back to our midline, down to our minimum, and I'll change colors one last time. We have a sinusoidal function here. Jackie rode on a miniature Ferris wheel at Canada's Wonderland in Toronto. The graph below shows Jackie's height in meters above ground. So this is the height in meters above ground with respect to time in seconds. So down here we have time in seconds. It says the data required will provide in progress. What is the value of the period? So looks to me like from max or from min to min. From min to min will give us our period, and that is from 4 to 20, which is 16 seconds. What does the period represent? It represents the time for one full circle in the Ferris wheel, one full revolution. One revolution of the Ferris wheel. What is the equation of the sinusoidal axis? The sinusoidal axis, which is really what we call the midline. That is the midline. And so we can see right here is the midline here at 3. It's between 5, our minimum, and 1, our maximum. So y equals 3. What does the midline represent? And the midline represents the height of the axle of the Ferris wheel. What is the value of the amplitude? The amplitude goes from 3 to 5, so the value of the amplitude, see, it goes from 3 to 5, so the amplitude is 2. What does the amplitude represent? And it represents the radius of the Ferris wheel. What is the value of the height intercept? The height intercept is 3. What does the height intercept represent on the Ferris wheel? It means at how high Jackie was in the Ferris wheel when time began. That's the height. Time began. Why is there not a time intercept? Why doesn't this function cross the x-axis, or why doesn't it cross the x-intercept or the time intercept? And the reason for that is if it crossed the time intercept, that it will go and be at 0, so that Jackie's seat in the Ferris wheel would hit the ground, and we can't have that, Jackie hitting the ground in a Ferris wheel. That's when the height would be 0, and of course we can't have the height being 0 for a Ferris wheel. Let's have a look at another example. You may want to pause the clip and attempt this one on your own. I will continue. When you breathe, the air entering your lungs has a positive velocity, and the air exiting your lungs has a negative velocity. The relationship between velocity in liters of air per second and time in seconds for an adult at rest can be modeled by this graph. What is the equation of the midline? So we have here the midline is actually at 0. Equation of the midline would be y equals 0. What does this represent? It represents the velocity between breaths. Represents the velocity between breaths. What is the amplitude of the function? The amplitude, of course, is the distance from the midline to the max, which in this case is 0.8. So we have 0.8 liters per second. What is the period of the function? And the period is how long it takes to go from max to max, or twice the distance between max to min. I'm just going to have a look at the sinusoidal axis here. And of course, this function, it goes back to the sinusoidal axis one full cycle. So there's a positive velocity when the air is entering, so entering and then exiting, and we have 5 seconds. And what does this represent in this situation? The time for one complete breath. Complete in and out breath, I guess. So in summary, what we need to know, you can determine the characteristics of a sinusoidal function from its graph. The period is the horizontal distance between consecutive maximum values or consecutive minimum values. It is also twice the horizontal distance between a maximum value and the next minimum value. So that's another option. Sometimes the graphs are in between units and it's hard to tell from maximum to maximum or minimum to minimum. So you may be able to, it's twice the distance from a maximum to the next minimum value. The equation of the midline is the average of the maximum and minimum values. So the distance between the max and the min value, halfway in between there, is the midline. The amplitude is the positive vertical distance between the midline and either the maximum or the minimum. So from the midline to the maximum or the midline to the minimum. It is also half the vertical distance between the maximum and the minimum. So if you know what it is from here to here, it's halfway in between, of course. And it is always a positive value. The amplitude is always positive.